Hello student, now we'll start the new chapter, binomial distribution. This chapter is for 5 marks in board examination. I will explain all the theoretical parts, short examples and all examples from the exercise 8.1. Now let us start the binomial distribution. Hello friends, now today we will start the last chapter, binomial distribution, and now let us study Bernoulli Trials. In this chapter we will learn binomial distribution, mean and variance of binomial distribution. Now let us recall. Many experiments are dichotomous in nature. For example, a tossed coin shows head or tail. That it means that it shows the two results. A result of student pass or fail. A manufactured atom can be defective or the non-defective. दोघांपैकी एक कुठलं तरी त्यामध्ये आन्सर असणार आहे. A response to a question might be yes or no. An eggs has hatched or not hatched. The decision is yes or no, etc. In such cases, it is customary to call one of the outcomes a success and other not success, or it is called the failure. एक success असणार आहे आणि दुसरा काय असणार आहे तर failure असणार आहे. For example, in tossing a coin, if the occurrence of the head is considered a success, then occurrence of tail is a failure. Now let us learn what is the Bernoulli trial. Each time we toss a coin or roll a die to perform any other experiment, we call it a trial. If a coin is tossed, say 4 times, आपण जर ती coin 4 वेळा toss केली, then what will happen? The number of the trials is 4. How many trials are there? 4 trials are there. Each having exactly 2 outcomes, namely success or the failure. ज्या वेळेस आपण टॉस करणार त्या प्रत्येक टॉसला एकदा सक्सेस असेल किंवा फेलर असेल, हेड असेल किंवा टेल असेल. The outcome of any trial is independent of the outcome of any other trial. Every trial is independent. In each of such trials, the probability of success or the failure remains constant. आधीचा इव्हेंट आणि नंतरचा होणारा इव्हेंट प्रत्येक ट्रायल ही कशी असणार आहे तर इंडिपेंडंट असणार आहे. अँड दॅट्स वाय in each of such a trial, the probability of success and the probability remains the constant. Such independent trials which have only 2 outcomes, की ज्यामध्ये 2 outcomes असतील, usually referred as a success or the failure, and they are called the Bernoulli trials. Success or the failure. Now what is its definition? That is, a trial of a random experiment are called Bernoulli trial if they satisfy the following conditions. Each trial has exactly 2 outcomes. First is success or the failure. The probability of success remains the same in each trial. Throwing the die 50 times in a case of 50 Bernoulli trials, in which each trial result in a success, say ज्यावेळेस आपण die toss करणार, okay, then what will happen? Say an even number. Success ला काय म्हणणार तर even number, throwing the die, and failure, that is an odd number, and the probability success P is the same. Odd number किती तर 3 आहे, even number किती तर 3 आहे. And their probability is 1/2 and 1/2. success P is the same for all 50 throws. Obviously, the success throws of the die are independent trial. If the die is a fair, okay, and has 6 numbers 1, 2, 3, 4, 5, 6 written on the 6 faces, then the probability of the success is 1 upon 2 and the probability of the failure is 1 upon 2. For example, consider a die to be thrown 20 times. If the result is an even number, consider it a success, else it is a failure. Odd आला तर failure समझो. Then P is equals to 1 upon 2 as there are 3 even numbers in possible outcomes. If in the same experiment we consider the result a success if it is a multiple of 3, then P is equals to 1 upon 3 as there are 2 multiples of 3 among the 6 numbers. Multiples of 3 are 3 and 6. Okay, therefore there are the 2 numbers. That is a 2 upon 6 means what? You will get here the probability is 1 upon 3. Both above trials are the Bernoulli trials. Now see this some solid example. 6 balls are drawn successively from an urn containing 7 red, 9 black balls. Tell whether or not the trial of drawing balls are Bernoulli trial. When after each draw the ball is drawn, okay, it is replaced, not replaced. What is happening here? That is, the 6 balls are drawn successively. That urn contains how many red? 7 red and 9 blacks. Okay, and the 6 balls are drawn. And how the trial is? It is replaced and not replaced. The number of trial is a finite. When the drawing is done with the replacement, the probability of success, say the red ball. How many total balls are here? That is a 7 plus 9. It is a 16. And suppose that if you want the red ball, and then it's a, say that it is a success. The success are upon consider them. Then here P is equals to 7 upon 16, which is same for all 6 trials. That is a draws. And hence the drawing of the balls with the replacement is a Bernoulli trial. प्रत्येकदा तुमची सक्सेसची व्हॅल्यू, पी ची व्हॅल्यू आणि क्यू ची व्हॅल्यू कशी असली पाहिजे? The constant. It should be not changed. Then this type of the trials are called the Bernoulli trials. When the drawing is done without replacement, भाई तिथनं बॉल काढायचा आणि तो बाजूला ठेवायचा. The probability of the success for the red ball in the first trial, it is a 7 upon 16. And in second trial, how many balls are there? One red ball is drawn. Then there is a 6 upon 15. In the second trial, is a 6 upon 15. If the first ball is drawn is red and is 7 upon 15, if the first ball drawn is a black and the so on. Clearly the probability of success is not same for all the trials, and hence the trials are not Bernoulli trials. आणि ज्या वेळेस आपण तो तिथे रिप्लेस करत नाही त्यावेळेस ते Bernoulli ट्रायल तिथे होत नाही. ओके, नेक्स्ट, binomial distribution. Now what is meant by this is the name of the chapter, binomial distribution. Consider the experiment of tossing a coin in which each trial result in success. Say head, tossing a coin. If there is head, then it is called a success, or the tail, then it is a failure. Let S with S and F denote respectively the success and the failure in each trial. Suppose we are interested in finding the ways in which we have one success in 6 trials. आपण ते कॉइन किती वेळा टॉस केला तर 6 वेळा टॉस केला. And suppose that I get the one success in 6 trials. Clearly, these 6 different cases are there as listed below. मग कोणकोणत्या 6 डिफरंट होतील तर पहिल्यांदाच आपल्याला सक्सेस मिळाला, हेड मिळाला आणि नंतरचे काय मिळतील टेल मिळेल. नंतर सेकंड टाइम आय गेट द सक्सेस, फर्स्ट इज नॉट सक्सेस अँड ऑल द रिमेनिंग नॉट द सक्सेस. इन थर्ड केस the third time I get the success, first and second not success, failure, and the last 3 are not failure. He is a failure. And in this way we get all the 6. Similarly, 2 successes and 4 failures can have, that is a 6 factorial. How many will be there? Sample space किती असणार आहे? पहिल्यांदा आपल्याला किती मिळाल? 6. Similarly, 2 successes and 4 failures can be 6 factorial upon 4 factorial into 2 factorial. Means what? We have the all these type of the 15 combination. त्यामध्ये 2 सक्सेस असले पाहिजे आणि 4 फेलर असले पाहिजे. जसं आपण वर इथे 6 मला कॉम्बिनेशन्स मिळाले सक्सेस साठी. I required only the single success. And how many sample space are there? How many trials was there? That is a 6. मग असे किती कॉम्बिनेशन्स होतील की ज्यामध्ये मला 2 सक्सेस आहेत आणि 4 फेलर्स आहेत. That is a 6 factorial upon 4 factorial into 2 factorial, and that's equals to 15 combination. But as n grows large, the calculation can be lengthy. To avoid this number, for certain probabilities can be obtained with the Bernoulli formula. For this purpose, let us take the experiment made up of 3 Bernoulli trials with the probabilities P and Q is 1 minus P for success and the failure. आणि तो फॉर्म्युला आपल्याला तयार करायचा आहे. मग आपण यामध्ये काय की बर्नॉली ट्रायल्सचा कन्सिडरेशन करणार आणि त्यामध्ये आपण 3 ट्रायल्सचा कन्सिडरेशन करणार आहे. 3 ट्रायल्स. ओके. फॉर दिस पर्पज लेट अस टेक द एक्सपेरिमेंट मेड अप ऑफ 3 बर्नौली ट्रायल्स with probabilities P and second probability is a P Q is equals to 1 minus P for the success and the failure respectively in each trial. किती trials? The 3 trials. The sample space of the experiment is set. Okay, tossing of it. If I get the all the success, 2 success, 2 success, again 2, single one, single one, single one, and no success. Okay. The number of the success is a random variable x and number of the success is a random variable. Means what? The first, if all are f, then it is a 0. 1 is s, then it is x is equals to 1. 2s असतील तर x ची value 2. 3s असतील तर x ची value 3. Therefore, the number of the success in a random is a random variable capital X and can take the values 0 म्हणजे एकही सक्सेस नाही, 1 म्हणजे एक सक्सेस, 2 म्हणजे 2 सक्सेस आणि 3 म्हणजे 3 सक्सेस. The probability distribution of the number of the success is as below. First is, if x is equals to 0, it means that no success. Means what? No success म्हणजे काय की सर्व काय असतील तर ff असतील. Here is ff, probability of n into probability of f into probability of all events are independent. Since the trials are independent and therefore q into q, then here you will get the q. Okay, one success म्हणजे एक s आला पाहिजे. Then it is written as in this manner: probability of s ff plus probability of f sf plus probability of f fs, and this can be again written as probability of s, probability of f and probability of f. and for all these 3 remaining is also. Now here the probability of S is P, probability of F is Q and Q. Next is also, here is a Q, P, Q plus Q, P and P, and in this way all are similar here. Okay, therefore it is a 3PQ square. Okay, for the 2 success, we will have the SSF, SFS, FSS and their probability, that is a P of SSF plus probability of SFS plus probability of FSS, and therefore it is written in this manner. Okay, again we will have here PQ plus P dot Q dot P plus Q dot P dot P, and all these 3's are here. How many P's? That is P into P, P square. P square into Q, P square into Q, P square into Q. That is when the 2 successes are there, then you will have 3 P square Q. And when a capital X is equals to 3, all 3 successes are there. Then the P, S, S, S. Then the P of S into P of S into P of S. It means that P of X is equals to 3 is equals to PQ. Thus the probability distribution of X is, when 0 success, it is a QQ, 1 success, 3Q square P, 2 success, 3Q P square, and 3 success, it is a PQ. Also the binomial expansion can be written as, now see this, the terms containing in this formula, in this table. कोणत्या प्रकारचे आहेत बघा ते, क्यू क्यूब येते, 3Q स्क्वेअर P आहे, नंतर 3PQ स्क्वेअर आहे आणि P क्यूब आहे. जर तुमचा अल्जिब्रा चांगला असेल, and this is the nothing but the expansion of Q plus P bracket Q. Okay, हा फॉर्म्युला, this is an expansion of Q plus P bracket Q. That is a Q plus P bracket Q is equals to QQ plus 3Q square P plus 3QP square plus PQ. Note that the probabilities 0, 1, 2 or 3 successes are respectively the first, second, third and the fourth terms in the expansion of P plus Q bracket Q. What is first here? That is a 0 success, means what? It is a QQ. 1 success, it means that 3Q square P. 2 success means what? 3QP square. And 3 success, it means that PQ. Okay. Also, we know that P plus Q is equals to 1. Since that is, it follows that the sum of these probabilities as expected is 1. Thus, we may conclude that in an experiment of n Bernoulli trials, the probabilities of 0, 1, 2, 3 n success can be obtained. If there are the n trials, then the first, second, third in this way. If there are n trials, then how many terms will be there? The n plus 1th term will be there. And here Q plus P bracket raised to n will be there. आता इथे बघा आपण 3 ट्रायल्स होत्या. Then Q plus P bracket raised to 3. If there are n trials, then here Q plus P bracket raised to n. To prove this assertion, that is this result, let us find the probability of X. In this way, probability of X, not n, not 0, probability of X. X success in an experiment of n Bernoulli trials. मध्येच कुठेतरी तो X असेल आणि ते सक्सेस आपण आता फाइंड आउट करणार आहोत. क्लिअरली in case of X success, there will be the n minus X failure. कारण की टोटल किती तर n आहे. X success असतील तर फेलर किती असतील तर n minus X. Now X success S and n minus X failure F can be obtained in n factorial upon x factorial into n minus x ways. Okay. Now x success and n minus x failures can be obtained n factorial upon x factorial into n minus x ways. In each of these ways, the probability of x success and n minus x failure can be written as in this manner. That is probability of x success and probability of n minus x failure. Now see this, these are the success x times probability of s, probability of s, probability of s, this is x times. What about the failure? Probability of f into probability of f into probability of f up to the n minus x times. And here this success, that is a p into p into p, this is the x times and this is the n minus x times. If you multiply it, then what you will get? P raised to x, and what here you will get? Q raised to n minus x. Thus, probability of getting x success in n Bernoulli trial is probability of x success out of the n trials, n factorial upon x factorial into n minus x factorial into p raised to x into q raised to n minus x. And hence, this is nothing but combination, that is ncx p raised to x into q raised to n minus x. Clearly, the p probability of x success, that is a ncx p raised to x into q raised to n minus x, is the x plus 1th term in the binomial expansion of q plus p bracket raised to n. Thus, the probability distribution of number of success in an experiment consisting of n Bernoulli trial may be obtained by the binomial expansion q plus p bracket raised to n, and hence this distribution of number of success capital X can be written as, that is a x success 0, 1, 2 up to the n. That is when it is a 0 success, nc0 p raised to x q raised to n. 1 success, nc1 p raised to 1 q raised to n minus 1. And in this way, up to the n, you will get ncn p raised to n into q raised to 0. The above probability distribution is known as binomial distribution. Just similar, you have learned. Here is a probability. Similar way, that is in the probability distribution. Here is a binomial distribution with the parameters n and p. Because for given values of n and p, we can find the complete probability distribution. It is represented in this manner. X follows the binomial distribution np. या प्रकारेच ते लिहिलं जातं and read as x follows the binomial distribution with the parameter np. The probability of x success, that is the p of capital X is equals to x, is always denoted by p of x, and it's given by the formula. This is the important formula. P of x is equals to ncx q raised to n minus x into p raised to x. The values of x are 0, 1, 2 up to the n, and where q is equals to 1 minus p. This px is called the probability function of the binomial distribution. Binomial distribution with n Bernoulli trial. Probability of success in each trial as p, and is denoted by binomial trials n and p, or x follows the binomial distribution np. Let us note that. What is that? The number of the trial should be fixed and the trial should be independent. Now the solved examples. First example, if a fair coin is tossed 10 times, find the probability getting first exactly 6 heads, at least 6 heads, at most 6 heads. Now in this problem, a fair coin is tossed 10 times, means what you will have the value of the n is equals to 10. Okay, the repeated toss of a coin are the Bernoulli trial. Let X denotes the number of the heads in an experiment of the 10 trials. Clearly X follows the Bernoulli Trials. X follows the binomial distribution with the value of n is 10. P is equals to 1 upon 2 and Q is equals to 1 minus P, that is 1 minus 1 upon 2, and hence Q is equals to 1 upon 2. What is the probability of capital X is equals to small x n Cx P raised to x into Q raised to n minus x? The value of P is 1 upon 2, n is 10. Therefore 10Cx 1 upon 2 bracket raised to x into 1 upon 2 bracket raised to n minus x. And if we simplify this, then you will get that is 1 upon 2 bracket raised to n. Exactly 6 success means what? X is equals to 6. P of capital X is equals to 6. 10C6, 1 upon 2 raised to 6, and 1 upon 2 raised to, here is a 10. Okay, we will write here 10. Okay. Or, sorry, 10 minus 6. 10 minus 6. Therefore, 10C6 can be written as 10 factorial upon 6 factorial into 10 minus 6 factorial, and 1 upon 2 bracket raised to 6. Again here you will get the 4, or overall you may have that is a 1 upon 2 bracket raised to 10 the regular tarike chale. Okay. Therefore here you will get 10 factorial can be extend up to the 6 factorial. म्हणजे वरचा आणि खालचा 6 कारण त्यात कट झालेला असेल. 10 into 9 into 8 into 7, 6 खालचा आणि वरचा गेट कॅन्सल. 10 minus 6 means what? It is a 4. 4 into 3 into 2 into 1, and 1 upon 2 bracket is to 10. And if you simplify it, then you will get P of capital X is equals to 105 upon 512. For this year, what is that? Exactly 6 success. Now next problem was at least 6 success, that is X is greater than or equals to 0. म्हणजे काय असणार आहे? Probability of X is equals to 6, 7, 8, 9 and the 10. Therefore again the formula is 10C6 1 upon 2 raised to 6 into 1 upon 2 raised to 4 plus 10C7 1 upon 2 raised to 7 into 1 upon 2 raised to 3, 10C8 1 upon 2 raised to 8 into 1 upon 2 raised to 2 plus 10C9 1 upon 2 raised to 9 into 1 upon 2 raised to 1 plus 10C10 1 upon 2 raised to 10 into 1 upon 2 raised to 0. And if we simplify it, and then you will get the terms are like this. Okay, या प्रकारे ती सर्व terms तुम्हाला ते मिळतील. Okay, and now from this you can take the common, that is 1 upon 2 raised to 10 means what? 1 upon 1024, and these are the terms in the remaining bracket. You can add, simplify it, and the probability of capital X greater than or equal to 6 is 193 upon 512. At most 6 success means what? That is X is less than or equals to 6. At most म्हणजे जास्तीत जास्त 6 success झाले पाहिजे त्यामध्ये. Therefore this can be again written as P of capital X less than or equals to 6 means what? That is equals to 1 minus P of capital X greater than 6. Just we can write here 1. That is a greater than 6 means what? 7, 8, 9, 10. Then you probably find out the number. And then again the substitute here with the values, here values. Okay, you will get the terms, and this is the calculation. You can perform this calculation. Okay, take 1 upon 1024 common, and in bracket you will get 120 plus 45 plus 10 plus 1 and 1 minus 176 upon 1024, and it is, if you simplify it, then you will get, that is the probability of capital X less than or equals to 6 is 53 upon 64. Now the next problem, 10 eggs are drawn successively with replacement from a lot containing 10% defective eggs. Find the probability that there is at least one defective egg. कमीत कमी एक तरी defective egg असला पाहिजे. 10% defective eggs. Okay, let आपल्याला defective eggs, let x denotes the number of the defective eggs in 10 eggs in the 10 eggs drawn. Since the drawing is done with the replacement, the trial are the Bernoulli trial. Therefore, probability of the success is 1 upon 10. Therefore, P is equals to 1 upon 10. Therefore, Q is equals to 1 minus P, and Q is a 9 upon 10. Therefore, P is 1 upon 10, Q is a 9 upon 10. N is equals to 10. Therefore, X follows the binomial distribution NP. N is 10 and P is 1 upon 10. Therefore, P of capital X is equals to small x is equals to 10cx 1 upon 10 raised to x into 9 upon 10 bracket raised to 10 minus x. Okay. Now what we want to find out, that is the question was at least one defective. At least one defective. Here the capital X therefore must be greater than or equals to 1. And for this we will find out the probability of complement. That is, P of capital X is greater than 1 is equals to 1 minus 10C0 1 upon 10 raised to 0 into 9 upon 10 raised to 10. Okay. या प्रकारची कॉम्प्लिमेंटची प्रोपर्टी आपण फाइंड आउट करणार. Okay. Therefore, here is a 1, 10C0 is 1 and again 1, 9 upon 10 raised to 10, and if you simplify it, then you will get 1 minus 9 upon 10 bracket raised to 10. Okay. Next topic is mean variance of the Bernoulli binomial distribution. Probability distribution मध्ये देखील आपण mean आणि variance, standard deviation हे बघितलं. इथे देखील these are the without the proof. X follows the binomial distribution with the mean or the expected value of random variable capital X denoted by mu or the E of X. Therefore, mu is equals to E of X is equals to NP, and the variance of X, that is the variance of X is equals to NPQ. Standard deviation X, that is the sigma, this is equals to sigma X is equals to variance of X. For example, X follows the binomial distribution NP where N is 10, P is a 0.4. Then find out E of X and the variance of X. Now here the solution N is equal to 10. P is a 0.4 and Q is a 1 minus P, that is a 0.6. What is the E of X? E of X is equals to NP. N is 10, P is a 0.4, and overall you will get here 4. Therefore, the variance of X is equals to NPQ. That's a 10 into 0.4 into 0.6, and then you will get 2.4. Now the next problem. Let the probability mass function of random variable capital X be. P of capital X is equals to the small x is a 4C x 5 upon 9 bracket raised to x into 4 upon 9 bracket raised to 4 minus x, where the values of x is 0, 1, 2, 3, 4. Then find the E of x and the variance of x. The solution P of capital X is equals to the small x is the binomial distribution with N is equals to 4, P is equals to 5 by 4, Q is 4 upon 9. E of x is equals to NP, that is the 4 into 5 upon 9 is equals to 20 upon 9, normal calculation. Variance of x म्हणजे काय की NPQ असतं 4 into the value of P into value of Q. Therefore, the variance of x is equals to 80 upon 81. Next problem, if the E of x is 6 and the variance of x is 4.2, then what are the values of N and P? हे देखील अतिशय सिंपल आहे. E of x ची व्हॅल्यू आपल्याला दिलेली आहे, NP दिलेला आहे, त्यामुळे म्हणजेच काय तर NP दिलेला आहे. व्हेरियन्स ऑफ x दिलेला आहे म्हणजे NPQ आपल्याला दिलेला आहे. आणि या दोघांचा इथे रेशो घेणार NPQ upon NP. That is 4.2 upon 6. That is NP get cancelled. You will get the value of the Q is a 0.7. Then what will the P? P is the 1 minus Q. That is 1 minus 0.7. That is the P is equals to 0.3. But what is the NP? NP is equals to 6. Substitute the value of here P 0.3. Therefore, N is equals to 6 upon 0.3. Multiplied n and d by 10, 60 upon 3, and that is equals to 20. Okay, therefore the p is a 0.3. Okay, the same value is here. Okay. Now we start the exercise 8.1. Now here we will start the exercise 8.1. A die is thrown 6 times. If getting an odd number is a success. Okay. Find the probability of 5 success, at least 5 success, at most 5 success. Let x the number of the success, that is the number of odd numbers. P the probability of getting an odd number in a single throw of a die, that is equals to, how many odd numbers are there? 1, 3, 5. 3 odd numbers are there, and therefore it is a 3 upon 6. Therefore P is equals to 1 upon 2, and Q is equals to also 1 minus P. That is the value of Q is 1 upon 2. N is equals to 6, because there are the 6 times. The probability of mass function capital X is given by P of capital X is equals to small x NCx P raised to x into Q raised to N minus x. Therefore P of x is equals to 6cx. The value of P is 1 upon 2 raised to x, 1 upon 2 raised to 6 minus x. And here 1 upon 2 raised to x into 1 upon 2 raised to 6 minus x. By laws of the indices, this plus x and minus x will be 0, and 1 upon 2 raised to 6. Now in first problem, that is a 5 success, the value of x is equals to 5. Therefore P of 5 is equals to 6c5, 1 upon 2 raised to 6. And if we take the calculation, then 6c1, that's the value, is equals to ncx is equals to ncn minus x, and its value is 6. And the 1 upon 2 raised to 6 means what? 1 upon 64 means what? You will get 3 upon 32 in this way. Hence the probability of 5 success is 3 upon 32. Next is at least for the second one. What is second? At least 5. Therefore here at least, this is the at least म्हणजे कमीत कमी जे 5 success त्याच्यापेक्षा जास्त असले तरी चालतील. Therefore here I had written P of capital X greater than or equal to 5. It means that P of 5 plus P of 6. 6c5 1 upon 2 raised to 6 plus 6c6 1 upon 2 raised to 6. And here 6c5, 6c6 1 upon 2, take common. Then you will get 1 upon 2 raised to 6. 1 upon 2 raised to 6 means what? 1 upon 64. This value is 6 and this is 1. 6 plus 1 is 7. It is a 7 upon 64. Hence the probability of at least 5 success is 7 upon 64. At most 5 success, that is P of capital X is less than or equals to 5. म्हणजे 5 पर्यंतच पाहिजे, up to the 5, not more than 5. And therefore we can find out by using its complement. That is nothing but P of 1 minus P of capital X greater than 5. And we know that P of 6, which is the 66 1 upon 2 raised to 6. And it is 1 minus 1 into 1 upon 64. And if we simplify, then you get 63 upon 64. Hence the probability of at most 5 success is 63 upon 64. Next is a fair dice is thrown 4 times. If getting a doublet is considered a success. Doublet means what? If you throw the dice and if you are getting 1 1, 2 2, 3 3, this is called the doublet. Find the probability of the 2 success. Okay. Let X denote the doublets. P the probability of getting a doublet when a fair dice is thrown. how many doublet will be there? That is 6. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Total are 6 and upon 36 sample space. Then here 6 upon 36, that is equals to 1 upon 6. Okay. And here that is a Q is equals to 1 minus P, and its value is a 5 upon 6, not getting the W. Now here n is equals to 4, number of the throw. X follows the binomial distribution NP. The value of n is 4 and P is 1 upon 6. The PMF of X is given by P of capital X is equals to small x, NCX, P raised to X into Q raised to n minus X. Therefore, here NCX 1 upon 6 raised to X and 5 by 6 raised to 4 minus X. The values of X is 0, 1, 2, 3, 4. 2 success. That is, capital X is equals to 2. Therefore, here P of 2 is equals to 4C2, 1 upon 6 raised to 2 and 5 by 6 raised to 4 minus 2. 4C2 means what? 4 factorial upon 2 factorial into 2 factorial. 1 by 6 bracket square, 5 by 6 bracket square. And if you simplify, 4 factorial means what? 4 into 3 into 2 factorial. 2 factorial as it is, 2 into 1, 1 by 36, 5 by 6, that's a square, 25 upon 36. And if you simplify, then you will get 25 upon 260. Therefore, the probability of true success is 25 upon 260. What's the problem? There are 5 defective atoms in a large bulk of atoms. What is the probability that a sample of 10 atoms will include not more than one defective? Not more than one defective. The probability of here we require the defective. Let X denote the number of defective atoms. P is the probability of defective atom. What's the percentage of defective? Is 5%. Therefore, P is equals to 5%, 5 upon 100, and that is equals to 1 upon 20. What is the value of Q? Q is 1 minus P. That is 1 minus 1 upon 20. It's a 19 upon 20. And therefore, X follows the binomial distribution NP, 10 and 1 upon 20. The PMF of capital X is given by P of capital X is equals to NCX, P raised to X, Q raised to n minus X. And therefore, P of X is equals to 10Cx, 1 upon 20 raised to X, 19 upon 20 bracket raised to 10 minus X. And the values of X are 0, 1, 2, 3 up to 10. What is the probability? The sample of the 10 atoms will include not more than one defective atom. Not more than means what? P of capital X is less than or equals to 1. Then we want to find out the probability of 0 and probability of X is equals to 0 and X is equals to 1. Therefore, here 10C0, 1 upon 20 raised to 0, 19 upon 20 raised to 10 minus 0 plus 10C1, 1 upon 20 raised to 1 into 19 upon 20 raised to 10 minus 1. Okay, and here 10C0 is 1, this is 1, 19 upon 20 raised to 1 plus 10C1, this is a 10, 1 upon 20 into 19 upon 20 and bracket raised to 9. And again, if we simplify, here's the simplified figure. The 19 upon 20 raised to 10, 19 upon 20 raised to 9. Take 19 upon 20 raised to 9 as a common, and here you will get 19 upon 20 plus 10 upon 20 in this way. And then if we simplify this, you will get 19 upon 20 raised to 9, 29 upon 20, and in this way, again the simplification you will get 29 into 19 raised to 9 upon 20 raised to 10. Okay, हे दोन हे 9 असणार आहे आणि हा 1 असणार आहे. It will become 10. The probability that a sample of 10 atoms will include not more than one defective is 29 into 19 raised to 9 upon 20 raised to 10. 5 cards are, next problem, 5 cards are drawn successively with replacement from well-shuffled decks of 52 cards. Find the probability that all 5 cards are spade. Only 3 cards are spade and none is a spade. Okay. What is here? 5 cards are drawn. With replacement, find the probability that the spade. Okay. Let X denote the number of the spade card. P, the probability of drawing the spade card from the pack of 52 cards. Since there are the 13 spade cards that we know, 13 spade cards in the pack of 52 cards. Therefore, it's a probability 13 upon 52 and that's equals to 1 by 4. But what is the value of Q? Q is equals to 1 minus P as P plus Q is 1. Therefore, Q is equals to 1 minus 1 by 4 and the value of Q is 3 by 4. And here we have the spade card असण्याची probability किती? The one P is 1 by 4 and non-spade card that is a 3 by 4. N is equals to 5. Okay, we have here N is equals to 5. 5 cards are drawn. Therefore, N is equals to 5. X follows the binomial distribution NP. N is 5 and P is 1 by 4. The probability of mass function of capital X is given by probability of capital X is equals to small x n c x p raised to x q raised to n minus x. The value of n is 5 c x, p is 1 by 4 raised to x, 3 by 5 raised to 5 minus x, x is equals to 0, 1, 2 up to 5. All 5 cards are this spade. That is P of capital X is equals to 5. P of 5, we have 5C5, 1 by 4 raised to 5, 3 by 4 raised to 5 minus 5. And here 5C5 is 1, 1 by 4 raised to 5, 3 by 4 raised to 0. This value is 1. And next, what is happening? 1 into 1 raised to 5 is again 1. 4 raised to 5 means what? 1024. Okay, 4 raised to 5 means what? 2 raised to 10. And its value is 1 upon 1024. Okay. Therefore, the probability of all 5 cards are displayed is 1 upon 1024. Next, probability only 3 cards are spade. Therefore, capital X is equals to 3. Therefore, P of 3 is equals to 5C3. Again 1 by 4. There is a 1 by 4 raised to 3 and 3 by 4 raised to 5. And here I will write here that is a 5C3 means what? 5 factorial upon 3 factorial into 2 factorial. Here is again 3 by 4 asnare. Here is also 3 by 4. I will write here 3 by 4. Okay. Here is a 3. Okay. Now the next is 1 by 4 raised to 3 means 1 upon 64. 3 by 4 raised to 2 means what? 9 upon 16. And if you simplify it, then you will get 45 upon 512. Therefore, the probability of only 3 cards are spade is 45 upon 512. P. Next, none of the card is a spade. That is, P of capital X is equals to 0. Means what? P of 0. Here, the value of X is 0. 5C 0, 1 by 4 raised to 0. 3 by 4 raised to 5 minus X means what? 5 minus 0. The value of 5C0 is 1. 1 by 4 raised to 0 is 1. 3 by 4 raised to 5. And if you simplify it, then you will get 243 upon 1024. And therefore, the probability of none of these card is spade is 243 upon 1024. Next problem. Probability that a bulb produced by a factory will fuse after 150 days of the use is 0.05. Find the probability that out of the 5 bulbs, none will fuse, not more than 1, more than 1, at least 1 will fuse after 150 days of use. Okay. Now let X denotes the number of the fuse bulb. P the probability of the bulb produced by a factory will fuse after 150 days of use. What is that probability? It's a given, which is 0.05. Okay, that is the value of P is given. Again, the Q is equals to 1 minus P, and that is 1 minus 0.05. Therefore, Q is equals to 0.95. Here P is a 0.5 and Q is a 0.95. N is equals to 5. X follows the binomial distribution NP. N is equals to 5 and P is a 0.01. Therefore, probability of mass function capital X is given by probability of capital X is equals to small x NCx P raised to x Q raised to N minus x. Substitute the values of the N, P and Q, and the value of X is 0, 1, 2, 3 up to 5. None of the bulb produced by a factory will fuse after 150 days of use. Means capital X is equals to 0. Substitute X is equals to 0. Therefore, P of 0 is equals to 5C0, 0.05 raised to 0, 0.95 raised to 5 minus 0. And that is a 1 into 1 into 0.95 raised to 5. And it is a 0.95 raised to 5. Next, therefore, the probability that none of the bulb will fuse after 150 days is equals to 0.95 raised to 5. What about the next? Find the probability that not more than one bulb will fuse after 150 days of use. Not more than one. X means what? Probability of capital X less than or equals to 1. Here the P of 0 and the P of 1. Again we will find out their values. 5C0 because the value of X is 0. 0.05 raised to 0, 0.95 raised to 5 minus 0. And next is 1. The value of X is 1, 5C1. 0.05 raised to 1 and 0 into 0.95 raised to 4. And if you simplify it, then you will get 1. Again here 1. 0.95 raised to 5. Here 5C. Here is a 5 and okay. This is the values. And here again you will take the 0.95 as a common. Then you will get here in bracket 0.95 plus 5 into 0.05, and if you simplify it, then you will get 0.95 plus 0.25. It's a 1.25 into 0.95 raised to 4, and hence it is a 1.2 into 0.95 raised to 4. Therefore, the probability that not more than one bulb will fuse after 150 days is 1.2 into 0.95 raised to 4. Now, third is probability of more than one bulb fuse after 150 days. Okay, more than one. That is the P of capital X is greater than 1 is equals to 1 minus P of capital X less than or equals to 1. And hence 1 minus 1.2 into 0.95 raised to 4. The probability that more than one bulb fuse after the 150 days is 1 minus 1.2 into 0.95 raised to 4. Last is a probability at least one bulb fuse after 150 days. Means probability of capital X is greater than 1. Means what? 1 minus P of 0. And we can substitute the values. X is equals to 0. 5C0, 0.05 raised to 0, 0.95 raised to 5 minus 0. That is 1 into 1 into 0.95 raised to 5, and you will get 1 minus 0.95 bracket raised to 5. Hence the probability that at least one bulb fuse after 150 days is 1 minus 0.95 bracket raised to 5. Now the next problem. A bag consists of 10 balls, each marked with one of the digit 0 to 9. If 4 balls are drawn successfully with replacement from the bags, what is the probability that none is marked with the digit 0? Okay, let X denotes the number of the balls marked with the digit 0. P The probability of drawing a ball from 10 balls marked with the digit 0. One digit is there, therefore it's a probability of 1 by 10. And what about the Q? Q is equals to 1 minus P. That is 1 minus 1 upon 10, which is 9 upon 10, the value of Q. Therefore here P is 1 by 10 and Q is a 9 by 10. The PMF of capital X is given by P of capital X is equals to small x, NCx, P raised to x, Q raised to n minus x. Therefore P of x is equals to 4cx, 1 by 10 raised to x and 9 by 10 raised to 4 minus x. The values of x are 0, 1, 2, 4. P, the none of the ball marked with the digit 0. Therefore, P of capital X is equals to 0. P of 0, 4C0, 1 by 10 raised to 0, 9 by 10 raised to 4 minus 0. Here is a 1 into 1, 9 by 4 raised to 10. And finally, you will get the answer, that is a 9 by 10 raised to 4. Hence, the probability that none of the bulb marked with the digit 0 is 9 by 10 raised to 4. Okay. Now we will go to the lottery tickets. A person buys a lottery tickets in 50 lotteries, in each of which his chance of winning a prize is 1 upon 100. Find the probability that he will win prize. A person buys the lottery tickets in 50 lotteries. And what about its winning chances? Winning chances is 1 upon 100. At least once, exactly once, at least twice. Let X denotes the number of the winning prizes. P is equals to the probability of winning a prize. Therefore, P is equals to 1 upon 100. Okay. Then what about the Q? Q is equals to again 1 minus P. That is 1 minus 1 upon 100, which is a 99 upon 100. Okay. Therefore, here n is equals to 50. X follows the binomial distribution. 50, 1 upon 10, 1 upon 100. The PMF of X is given by P of capital X is equals to NCx, P raised to X, Q raised to n minus X. P of X is equals to 50Cx, substitute the value of P and Q. 1 by 100 raised to X, 99 upon 100 raised to 50 minus X. The values of X is a 0, 1, 2 up to 50. A person wins a prize at least one. कमीत कमी at least one. एकापेक्षा जास्त असले तर चालते. Therefore, P of capital X is greater than or equals to 1. And we can find out in this manner. That is P is equals to by using the help of the complementary probability. And this value of this is nothing but 1 minus P of capital X exactly less than 1. May less than 1 म्हणजे काय की P of 0. And we will find out the P of 0 by using the formula. म्हणजे काय 1 minus 50C0 1 upon 10 100 raised to 0. 99 raised to 99 upon 100 raised to 50 minus 0. And if we simplify, it is 1 minus 1 99 upon 100 raised to 50. Therefore, the answer is the probability of winning a prize at least 1 is 1 minus 99 upon 100 bracket raised to 50. A person wins exactly one prize. That is P of capital X is equals to 1. P of 1, that is 50C1, 1 upon 100 raised to 1, 99 upon 100 raised to 50 minus 1. And if we simplify it, then you will get 50 into 1 upon 100 means what? You will get 1 upon 2. 99 upon 100 bracket raised to 49. Hence, the probability of winning a prize exactly 1 is 1 upon 2 into 99 upon 100 bracket raised to 49. Next is P, a person wins a prize at least twice. Means what? Probability of capital X greater than or equals to means you will get here 1 minus, it's a complementary आपण इथे लिहित असतो. एक दोनापेक्षा जास्त ते सर्व फाइंड आउट करण्यापेक्षा आपल्याला हे फाइंड आउट करणे जास्त सोपं असतं. 1 minus P of capital X less than 2. Therefore, it is a 1 minus P of 0 plus P of 1. इथे P of 0 ची लिहिणार, इथे P of 1 लिहिणार. and substitute the values. 50C0, 1. 1 upon 100 raised to 0 is 1. 99 upon 100 raised to 50. 50C1 means what? 50 into 1 upon 100 into 99 upon 100 raised to 49. And you will get 1 minus 99 upon 100 raised to 50 plus 1 upon 2 into 99 upon 100 raised to 49. And here, if we simplify it, that is a 99 raised to 49. If we take the common, 99, that is nothing but the 149 into 99 raised to 49 upon 100 raised to 50. Next is, hence the probability of winning a prize at least. Okay. At least, here is a at least twice. Okay. At least twice. Here I will write. You can perform this calculation. Okay. Next is a, in a box of floppy disk, it is known that 95% will work. Okay. A sample of 3 disks is selected at random. Find the probability that none, 1, 2, all 3 of the sample will work. Now see this here. X is number of the disks that is working. P the probability that floppy works. What is the probability? सगळ्यात जास्त 95% means what? 95 upon 100. That is the P is equals to 19 upon 100. Sorry, 19 upon 20. Simplify the letter. And Q is equals to 1 minus P. That is the Q is equals to 1 minus 19 upon 20. If you simplify, you will get 1 upon 20. Now N is equals to 3. If you are selecting 3. X follows the binomial distribution NP. N is 3, P is 19 upon 20. The PMF of X is given by P of capital X is equals to small x n c x. P raised to X, Q raised to N minus X. Therefore, P of X is equals to 3Cx, 19 upon 20 raised to X, 1 upon 20 raised to 3 minus X. The values of X is 0, 1, 2, 3. Okay. None of the floppy disks work. That is P of capital X is equals to 0. And it is a P of 0, 3C0, 19 upon 20 raised to 0, 1 upon 20 raised to 3 minus 0. And you will get 1 into 1 into 1 upon 20 raised to 3. Therefore, P of 0 is equals to 1 upon 20 raised to 3. Here is the probability that none of the floppy disks will work is 1 upon 20 raised to 3. P. Exactly one floppy disk work. P of capital X is equals to 1. Therefore, P of 1 is equals to 3C1. 19 upon 20 raised to 1. 1 upon 20 raised to 3 minus 1. 3C1 means what here? 3. 19 upon 20 into 1 upon 20 raised to 2. Okay, and this we can again simplify. That is a 20 raised to 1 and 20 raised to 2. That is a 20 raised to 3. And here 19 nanta. Therefore, it is a 3 into 19 upon 20 raised to 3. Here is the probability that exactly one floppy work is, that is a P of 1 is equals to 3 into 19 upon 20 raised to 3. Next, probability exactly 2 floppy disk work. Floppy disk work. Okay. Exactly 2 floppy disks work. That is the P of capital X is equals to 2. Therefore, it is a P of 2, 3C2, 19 upon 20 raised to 2, 1 upon 20 raised to 3 minus 2. And therefore, it is a 3 factorial into 3 minus 2 factorial into 2 factorial means what? 3 into 2 factorial, 19 raised to 2, 20 raised to 2, 1 upon 20. And again, if we simplify this, these terms get cancelled. You will get here 3, 19 raised to 2 and 20 raised to 3. This is 2 and 1, that will become 3. Hence, the probability that exactly 2 floppy disks work is equals to 3 into 19 raised to 2 and 20 raised to 3. That is, the next is P, all 3 floppy disks work. P of capital X is equals to 3. P of 3, 3C3, 19 upon 20 raised to 3, 1 upon 20 raised to 3 minus 3. And here you will get 1, 19 upon 20 raised to 3, 1 upon 20 raised to 0. And hence you will get P of 3 is equals to 19 upon 20 raised to 3. And hence the probability that all three floppy disks works, I want to write here, is 19 upon 20 raised to 3. Now the next problem, find the probability of throwing at most 2 6s in 6 throws of a single die. Okay, find the probability of throwing at most 2 6s in 6 throws of a single die. Let X denotes the number of the success. P the probability that a die shows 6 in a single throw. एक थ्रो जर केला तर एकदा आपल्याला येऊ शकतं. Therefore it's a probability of 1 upon 6. P is equals to. What about the again Q? Q म्हणजे काय? Again 1 minus P. That is 1 minus 1 upon 6 is equals to 5 by 6. N is equals to 6. We have given that. That is in 6 throws of a single die. N is equals to 6. Therefore X follows the binomial distribution NP. N is 6 and P is 1 by 6. The PMF of X is given by P of capital X is equals to small x. NCX P raised to X Q raised to N minus X. P of X is equals to 6x 1 by 6 raised to X 5 by 6 raised to 6 minus X. The values of X is 0, 1, 2 up to 6. At most 2 6s. At most 2 6s. That is the P of capital X is less than or equals to 2. Then its values 0, 1 and 2. मग P of 0 ची असणार आहे, P of 1 ची असणार आहे आणि P of 2. 0 means what? 6 is 0, 1 by 6 raised to 0. 5 upon 6 raised to 6 minus 0. 6 is 1, 1 by 6 raised to 1. 5 by 6, 6 minus 1. And the last is 6 is 2, 1 by 6 raised to 2. 5 by 6 raised to 6 minus 2. And hence after simplifying, you will get 1 into 1 into 5 by 6 raised to 6. Plus next is 6c1 म्हणजे काय? 6. 1 by 6 raised to 1, 5 by 6 raised to 5. पुढे काय? 6c2 means what? 6 factorial into 2 factorial and 6 minus 2 factorial means what? 4 factorial. आणि पुन्हा नेहमीप्रमाणे 1 by 6 raised to 2, 5 by 6 raised to 4 and simplify करणार आहे. पहिलं किती येणार? 5 by 6 raised to 6. What about the second? 5 by 6 raised to 5. Okay, हा 6 कट होणार. And what about here? 6 into 5, 4 factorial per then 4 numerator denominator get cancelled. You will get 6 into 5 upon 2, 1 by 6 raised to 2, 5 by 6 raised to 4. And again if we simplify, 5 by 6 raised to 6 plus 5 by 6 raised to 5 plus 6 into 5 upon 2 into 1, 1 by 6 square 5 by 4 raised to 6. And here 5 by 6 plus 5 by 6 raised to 4 plus 15 into 1 upon 16. 1 by 36 into 5 by 6 raised to 4. आता 5 by 6, 5 by 6, 5 by 6 raised to 4 common. Then what you will get? 5 by 6 raised to 2, 5 by 6 raised to 1, and here 15 by 36. And again if you simplify, 25 upon 36 plus 5 by 6 plus 15 upon 36. And if you simplify it, then you will get here 25 plus 30. If you take the LCM, 25 plus 30 plus 15 upon 36, and you will get 70 upon 36, 5 upon 6 raised to 4. And again the simplification, you will get 7 by 3 into 10 upon, here is a 12 into 5 by 6 raised to 4. Again you will get here 5 by 6 raised to 5. Therefore 7 by 3 into 5 by 6 raised to 5 by 6 raised to 5. Hence the probability of throwing at most 2 6s is 7 by 3, 5 by 6 raised to 5. Okay. Now the next problem. It was a repeated problem. It is known that 10% of certain articles manufactured are defective. Okay. 10% defective. What is the probability that in random sample of 12 such articles, 9 are defective? Okay, X denotes the number of defective articles. P the probability of defective article, it is given always, that's the 10%. Okay, That is a 10 upon 100 means P is equals to 1 upon 10. What about the Q? Q is equals to 1 minus P. That 1 minus 1 upon 10 and Q is equals to 9 by 10. Therefore, P is 1 upon 10, Q is a 9 by 10. Given that N is equals to 20, X follows the binomial distribution. NP, N is 12, P is 1 by 10. The PMF of capital X is given by. That is, the P of capital X is equals to X. NC X, P raised to X, Q raised to N minus X. Therefore, the value of N is 12Cx, P is 1 by 10 raised to X, Q is 9 by 10 raised to 12 minus X. The values of X 1 to up to the 12. That is the 9 defective articles. That is, the P of capital X is equals to 9. Therefore, P of 9 is equals to 12C9, 1 by 9 raised to 1 by 10 raised to 9. 9 by 10 raised to 12 minus 9. And if you simplify it, then you will get 12 factorial upon 9 factorial into 3 factorial. 1 by 10 raised to 9, 9 by 10 raised to 3. And again, if you simplify, that is, the 12 factorial can be written as 12 into 11 into 10 into 9 and 9 factorial. 3 into 2 into 1. 1 upon 10 raised to 9 into 9 raised to 3 upon 10 raised to 3. And if we simplify it, 9 get cancelled. And here you will get, that is these two terms, that is 3 into 6, and here you will get 2. That is a 2 into 11 into 10, 9 raised to 3, 10 raised to 12. Therefore, 22 into 9 raised to 3 upon 10 raised to 11. Hence, the probability of getting 9 defective articles is a 22 into in bracket 9 raised to 3 upon 10 raised to 11. Okay. Now, the next problem is, given that X follows the binomial distribution NP. Okay. N is equals to 10, P is equals to 0.4, then find E of X and the variance of X. Okay. And one by one we will solve it. Given N is equals to 10 and mu is equals to, that is the mean is a 0.4. Here Q is equals to 1 minus P. Sorry, here that is the P is equals to 0.4. N is equals to 10. Q is equals to 1 minus P. That is 1 minus 0.4, which is 0.6. Okay. Now the next is E of X. We want to find out mu. That is E of X, expected value, NP. That is a 10 into 0.4, that is equals to 4. Variance of X is NPQ. N is 10, P is 0.4. Okay. And Q is a 0.6. And if we take their product, you will get 2.4. Okay. Therefore, E of X is 4 and the variance of X is 2.4. Next, given that P is equals to 0.6 and E of X is 6. E of X is NP. E of X is a 6. N into P means what? 0.6. N is equals to 6 upon 0.6. If you multiply N and D by 10, you will get 60 upon 6, and that is nothing but the 10. Therefore, now here Q is equals to 1 minus P. Therefore, Q is equals to 1 minus 0.6, which is 0.4. Again, the variance of X is NPQ. Means what? 10 into 0.6 into 0.4, that is a 2.4. And hence N is equals to 10, and variance of X is 2.4. What about the last? That is the last no. That is N is equals to 25 EX. E of X is 10. E of X. Okay. Third now. Now see, this is the third problem. What is here? If N is equals to 25, E of X is 10, then find P and the SD of X. Okay. See this here. N is equals to 25, E of X is a 10. P is equals to, that is a 10 upon, that is, we know the result. What is that result? Here is the, I will write here. Then E of X is equals to NP. Okay. What is the value of E of X? It is a 10. N is 10, and that's equals to, here is the, that is equals to n is 25 and this is the p. Therefore, I had written directly here. Therefore, p is equals to 10 upon 25 and that is nothing but 2 by 5. The value of q is 1 minus p. 1 minus 2 by 5 means what? 3 by 5. The variance of x is npq. That is n is 25, p is 2 by 5, q is 3 by 5. And if we simplify this, 5, 25 and 25 get cancelled, 2 into 3, 6. And the SD, that is the variance of x, that is the SD is equals to root of 6. Therefore, hence p is equals to 2 by 5 and the SD is the root of 6. Now the next is the next problem. N is equals to 10 and E of x is 8. Then find the variance of x. Okay, we want to find out here the variance of x. Again here E of x, I will write here E of x is equals to, okay, E of x is equals to np. What is the value of n? Is 8. 8 is equals to np, but n is equals to 10. Therefore, it is a 8 is equals to 10p, and hence p is equals to 8 by 10, that is equals to 4 by 5. Therefore, q is equals to 1 minus p. That 1 minus 4 by 5 is equals to 1 by 5. Therefore, variance of x is equals to npq. Okay, that is a 10 into 4 by 5 into 1 by 5. And if we simplify it, and then you will get 8 upon 5. This is the variance of x, that is a 8 upon 5. And in this way, we are completing here the first exercise. Okay, now we'll see in the next video. Till then, goodbye.